Chapter 5, Day 2. This first slide right here is actually number 14 from your homework. Okay, I went through this problem yesterday on the video, so go back to day 1 if you had trouble with that problem and look through the last slide and also the video explanation for help. All right, let's take a look at just an application here, and let's try to make sense of this before we go on to today's topic. So in 2017, the iPhone 8 cost $700. In 2018, 1 year later, it costs $1,000. How much did the cost increase? Well, the cost increase was from 700 to 1,000. Subtract those two numbers, 1,000 minus 700, you get 300. So what is the change in the cost per year? So it costs an extra $300 per year. That's how much the cost increased. Well, that seems kind of obvious. But let's take a look at another example. The first iPhone that was sold was in 2007 for $600. So how much did the cost increase from 2007 to 2018 right here? Well, from 2007 to 2018, it went from $600 to $1,000, so that is an increase of $400. But that increase wasn't for 1 year. How many years was that? Well, that's 11 years. So that's $400 for 11 years. So what is the average change in the cost per year? So in other words, if it went up $100 per year, it would have gone up $1,100. If it went up $50 per year, if you take 50 times 11, that is 550. So it's less than that even. So how do we figure out how much it went per year? Well, it was $400 for 11 years. So we take 400 divided by those 11 years, and that gives us $36 per 1 year. So again, you take 400, that's how much it was for 11 years, divide it, split it equally among the 11 years, and it actually ends up to be, this is approximately, it actually ends up to equal $36 and about 36 cents. So that means that it's about $36 for each year. And what that is called the average rate of change. So that's the average change, because it might not have changed $36 exactly per year, but overall the average was that. Maybe 1 year it went up 50 and the next year only went up 20, etc. So that's what we mean by average change or average rate of change. And that's what we're going to work on today, is rate of change. So we are going to talk about rate of change, and that is the change in our dependent variable, which is our y values, compared to the change in our independent variable, our x values. So really what this is, rate of change really is it's how fast we're increasing or decreasing. So how fast increasing or decreasing. And what that really is, if you remember from before, is that really is our slope. And we're going to get into more of that later on. So it's the ratio that compares the average change in the x values for a given time period or interval. So let's take a look at an example, and maybe this will help make it more clear. So it says the table shows the average temperature for 5 months in a certain city. find the rate of change for each time period. And during which time period did the temperature increase at the fastest rate? So the first thing we're going to do is we are going to find the rate of change for each time period. Okay, so this is kind of going back to like our iPhone example. Let's look at how much it changed for a certain time period. So the first one we're going to look at is we're going to look at the change from 2 months to 3 months. And these are our changes from 2 to 3 months. So if we look at our change in temperature, how much did it change? The change was 0. And that change is our y values. This is our y values, and this is our x values. And so it changed 0 in 1 month. Okay? So our average rate of change is equal to 0 degrees per month. Okay, well that's kind of obvious, but let's move on. Okay, so let's go on to another rate of change. Let's look at another time, the next time period. So the next time period would be from 3 months to 5 months, right here. So now I'm going to actually not block that all in like that. Hard to see. So now we're looking at this time period. So let's look at how much did it change? Well, the change in temperature from 56 to 63 was it changed 7 degrees, but that was over 2 months. Okay, so if it changed 7 degrees in 2 months, what would be every month? That would be 3.5. So that's, it changed on the average 3.5 degrees per every month. So now let's look at our next time period. Let's look at another time period. Let's look at from 5 months to 7 months. So let's take a different color here. How much did it change? From 63 to 71, it changed 8 degrees. Let's clean that up a little bit. So it changed 8 degrees, but in how many months? Again, 2 months. So what's the average? Well, that average would be 4 degrees per month. So now so far, 4 degrees per month is the greatest increase. But let's look at our last time frame to make sure. So now let's look at between, oops, that is not what I wanted to do. Hold on, let me get a different highlight color. So let's look at 7 to 8 months. So how much did it change between 7 and 8 months? Well, the change right here, oh, it did not let me use a different color. Here we go, let's try again. How much did it change? It only changed 1 degree per, and then 7 to 8 months is 1 month. So that average rate of change is 1 degree per month. So what is the greatest? Okay, the greatest increase, that's what we want to try to find. The greatest increase then is, we want to find during which time period did the temperature increase at the fastest rate. So during which time period did the temperature increase at the fastest rate? Okay, and that fastest rate of increase was this right here. That was 8 degrees in 2 months, which is 4 degrees per month. So the answer to that question is the time period of, that would be 5 to 7 months. Okay, so that is our greatest increase right there. So let's see what this looks like on a graph. So when we graph this, we have our x's just like normal and our y's. And remember, it's the change in the y values compared to the change in the x values. So the temperature depends on the month of the year it is. That makes sense. So we know that our temperature is our dependent variable, and that is our y value. So this is going to be our independent variable, is our months. So the temperature depends on the month of the year it is. So we have month 0, we have month 2, we have month 4. I'm just going to go up by 2s and skip a line. And our temperature, we have to look at our temperatures, but the smallest temperature that we had was 56 and the largest was 72. So I'm not going to start numbering this 0, 2, 4, 6. I'm going to run out of space. So I'm going to use that little gap in the scale symbol, and I'm going to start labeling this at 50 degrees, and then I can go up probably by 2s. So 52, 54, 56, this would be 58. This would be 60, 62, 64, 66, 68. This would be 70, and up here 72. Let's see if I label 50, 52, 4, 6, 8. Nope. I need to fix this a little bit here. Thought I might have gotten off a little bit. So 58, this would be 60, this is 62, 64, 66, 68, 70, 72, and then this top one is 74. Okay, so I'm going to graph each of these segments of lines. So the first one is month 2 is 56. So that is this value right there. And then month 3 is also 56, so that's right here. So this segment of the graph is what we represented with this change. And notice the change was 0 degrees per month. Okay, so now let's look at the next one we did. Let's graph the next is from month 3 to 5. So month 5 went up to 63. So here's month 5. I'm going to go up to 62, 64 is right there, so 63 right here. So now I'm going to draw that segment of the line. And that was represented with our green. So we will shade that in green. And that is represented by our 3.5 per month. Our next increase went from month 5 to 7, and it went from 56 to 70, or from 63 to 71. So here is month 5, 6, 7, and 71. Now that's a little bit bigger circle than I would like. There we go. So there's another increase piece, and we had originally done that in orange. So that is this segment right there. And last but not least, we had the from 71 to 72, and that was at month 8. So that just went up to here, very small. And that was our last one we worked on. So if you look at each segment of the graph, okay, that also gives you indication of which was the highest per month. And if I go back and look at these, we can see it's hard to tell between the 3.5 and 4, and that's why you can't just rely on a graph. But this time period right here is also the steepest line. So that's our greatest increase. We can see it from our calculations, and lots of times you can see it from your graph. Okay, so here's another example. And this table shows the cost of mailing a 1-ounce letter in different years. Find the rate of change in cost for each time interval, and then again, during which time interval did the cost increase at the greatest rate. All right, so I'm going to work through this first piece with you from 1988 right here to 1999. And so the increase right here was, again, it increased the cost of a postage stamp, increased $0, okay, if over a 2-year span. So that is equal to 0 per year. That's the average increase. Okay, and so I'll highlight that right here. You can see that's that segment of the graph. Okay, I'd like you to pause the video right now, and I'd like you to work on 1990 to 91. So see if you can find from 90 to 91, what is the increase per year during that time period, and then start the video to see if you're getting it correct. Okay, for that time period, it increased 4 cents over a time period of 1 year, so that is 4 cents per year. And that is represented by this part of the graph. All right? So maybe you can already take a look at the graph from what I said before and try to figure out which is the greatest increase, but let's continue to calculate. So if you got that one right, great. Go on to 91 through 2004 and 2004 to 2008. So pause the video and try both of those. If you got stuck, then listen along right now and I'll explain again how we calculate this increase per year, the average per year. So from 1991 to 2004, that's this time period, this time interval. And the increase from 29 to 37 cents is an increase of 8 cents, and that is over a time period of 13 years. So when we divide 8 by 13, that is an increase of 61 cents per year. It's actually 0.61 cents, so it's not even 1 cent per year. And so it's a pretty small amount, and it's represented by this segment of the graph. And now, if you're still following along and not checking your work, I'd like you to try this last time period, which would be 2004 to 2008. And I'd like you to stop the video, try one more time to see if you can get this last piece. So if you're just joining us back, here's what you should have for that last increase from 2004 to 2008. The increase was 5. So it increased 5 cents in 4 years. So that is an increase of 1.25 cents per year. And that is represented from this portion of the graph. So hopefully you're starting to understand this. And again, if you look at the steepness or how fast it's increasing, the closer to vertical that line is, the higher the increase, or the greater the increase. So now we need to answer this final question. What time interval did the cost increase at the greatest rate? So which was the greatest increase? Even though 8 right here was the greatest number of cents it increased, that was over 13 years. So the greatest increase was this 4 cents that it went up in just 1 year. So the answer to this question would be the time period from 1990 to 1991. That was the greatest increase. All right, here's one other example, and I would like you to pause the video, read the question, and actually try to do this question on your own using what we've been working on in the other examples. Then restart the video for a last explanation. Okay, so what we are trying to do here is we are trying to find the rate of change during each time interval. And then we are going to also find during which time interval did the balance increase at the greatest rate. This table shows the balance of a bank account on different days of the month. So what I'm going to do is start working through each time interval. Okay, in the last questions, it kind of had some things set up for you, or at least in the last example, but we need to write the time period of day 1 to 6, and how much did it increase? When it goes from 550 to 285, that's actually a decrease of $265 over 5 years. So that means that is a decrease of $53 per day. So that is this first time period at from day 1 to 6. Okay, so now let's look at another time period. So now let's look at day 6 to 16. So that is this right here. And now it went from 285 down to 210. So it decreased $75 in 10 years. So again, divide those two numbers, and on average, that's like losing $7.50 per day. Now let's move on. Let's go to a different time interval, and let's go from day 16 to 22. And how much did it go up or down? Well, it actually stayed the same. So it was 0 in a period of 6 days, and so that is 0 per day that it decreased. And then our last time interval here is from day 22 to 30. And what was the decrease from day 22 to 30? That is a decrease of $35 over a span of 8 days. I'm just double checking that to okay, so decrease $35 over 8 days. So that is an average of subtracting 4 point, we'll round up here, 4.4. Actually, we don't need to round that much. It's 4.375, so $4.38 per day. Okay, now this is actually a discrete function because you can only have one amount of money, but we'll just leave it for right now and we will just answer the questions. So find the rate of change during each time interval. We did that. Which time interval did the balance decrease at the greatest rate? Well, it's this first one right here because it decreased $53 per day. All the other decreases right here are less per day. And that's how you look at average rate of change. It might have changed a whole bunch, but if it's over a whole bunch of years or days, then it's not going to be averaging out to be a lot per day. So you have to look at not only how much the change was, but over what time period and divide. So that's the end of our second day.